All right, everybody. Well, thanks for joining us. We'll go ahead and get started as other folks start to join. And you probably, or in some cases, you might be seeing a familiar face in our speaker. So thanks to those of you who joined us who, but anyway, we'll go ahead and get started. So good morning. Welcome to this first webinar of our 2021 Spring Science Seminar Series, brought to you by the Southeast Climate Adaptation Science Center. So in this virtual seminar series, we are highlighting SE CASC funded projects that support resource management actions across the Southeast. My name is Carrie Furness, and I'm the program manager here at the Southeast CASC. So Ashlyn here is sharing our agenda. So here's what to expect from our webinar today. So we'll go over a little bit of the meeting logistics, including getting some short feedback via a short poll, and then introduce our speaker for the day, who you probably aware is Dr. Brian Crawford. So he'll present for 40 minutes or so, and then we'll have plenty of time for Q&A at the end before we wrap up. So now I'll pass the mic over to Ashlyn Shore, our communications specialist here at the CASC, who'll give us a quick intro to our Zoom interface.
Thanks, Carrie, and good morning, everyone. Thank you so much for joining us today. As Carrie mentioned, I'd like to just quickly cover some of the features of the Zoom interface that we're using for the webinar, although by this point, I'm sure everyone on the call is basically a Zoom expert. But really quick, as noted on the slide here, the controls on the bottom left of your Zoom screen will allow you to connect to audio, either using your computer audio or the phone number listed on the meeting information link you received, also listed right here. So this is also where you can mute and unmute your audio. We will keep all lines muted throughout the presentation and ask that you also keep your video off just so we can lessen distractions during the presentation. And then in the middle of the bottom bar, you can access the chat window. And I'd encourage you, if you have some questions coming up during the presentation, just go ahead and submit those in the chat for discussion after the talk. So we'll be monitoring questions there, and we'll post them to our speaker during the Q&A session after the presentation. Lastly, we will be recording this webinar, and you can access that recording afterwards on the Southeast CASC website, on our Science Series webpage, and also on our YouTube channel. So I'll pass it back to you, Carrie.
Thanks, Ashlyn. So now we'd like to launch a short poll just to get a bit of information about who's with us today, and also help us know how to continue to get information out about these great webinars. So just give you, not quite half a minute, 45 seconds to fill that out. And then we'll share the results. So it looks like, yeah, about half the folks have joined in. Thanks for giving this feedback. Looks like the federal agencies and the universities are neck and neck. Okay, so I'll go ahead and end this and say thanks for filling this out. Do a quick share of the results. So it did look like the got a fair amount of federal agency participation, states, universities. And thank you all for reading the Southeast CASC newsletter. So, and for passing on the information to others. So, yeah, so nice to see the breadth of folks here, and maybe that helps you know how to pitch this presentation, perhaps, Brian. So now on to our presentation. So I'm pleased to introduce Dr. Brian Crawford. He is a postdoc conservation ecologist working in the Georgia Cooperative Fish and Wildlife Research Unit at the University of Georgia. His research integrates natural and social sciences to better understand and resolve human-caused impacts on wildlife. Much of his work focuses on developing decision support tools with partners such as biologists, managers, and decision makers to identify optimal management strategies for recovering at-risk species of herpetofauna, reptiles and amphibians, for those of you who don't recognize that term. So he'll be talking with us today about results from a Southeast CASC research effort for which he was part of a research team that also included Dr. Clint Moore at the co-op unit. And that project was called Providing Science for the Conservation of Animals in the Southeastern Longleaf Pine Ecosystem, in which you can find more information about that project on our website. So without further ado, go ahead and take it away, Brian.
Thank you so much. Let me just share my screen here and we will get going. There we go. All right. Sorry. Well, thank you so much for having me this morning. Thanks everyone for making time out of their busy schedules to attend. I see a lot of familiar faces and new ones, and it's just great to see anybody who's not, my dog and my partner these days. So thanks for coming. Yeah. So Carrie went over the introductions. That's me. It's exciting to present this to you today because this is basically the first time we're presenting these fresh and new results besides to the people who have been intimately involved in them. So these are sort of new and hot off the presses, and there's a lot to talk about. So we're going to go through an application of structured decision-making today where we used it to create a range-wide strategic conservation plan for an imperiled species in the Southeast called the gopher frog. And throughout the process, I'm going to highlight how we use this to be sort of a good approach to conservation outcomes, and then also for just the collaborative outcomes that have occurred through getting a group of people together. As one participant said, locking them in a room and getting them to discuss something can have some real positive outcomes for the species in and of itself. So we're going to highlight the collaborative aspects of this process as well. I always like starting with acknowledgements because this is such a partner-driven approach, and the list of people who contributed to this could go on and on and on. And I forgot to mention at the beginning, we did this work under the Georgia Co-op unit with Clint Moore and John Mayers at UGA, and then just a lot of other partners involved. And I'll mention some of them throughout. But definitely just wanted to thank them for all their expert input, coming to workshops, contributing throughout. So before we get into the gopher frog, let's start more basic. Let's say you just want to save any imperiled species, like the gopher frog. Well, why is this challenging? I think the better question is, why isn't this challenging, right? We have so many reasons why this is hard. A lot of times we have multiple threats to species and so many different management options on the table that it's hard to know where to start. We often have with these rare species, there's rare data. There's a lot of uncertainty even about where we're starting from, let alone what the effects of management are going to be. And I think with all this choice problem and knowledge problem comes a tendency for the inertia problem. And that means that, we often are sort of confounded and we just kind of default back to these status quo strategies or business as usual approaches. And there's nothing inherently wrong with that. A lot of good is being done, but we don't necessarily know if there are better options out there. Like, we haven't explicitly evaluated that. And that could be a problem if we want the best possible outcome for these species. And then looking more broadly, if we're trying to achieve conservation at scale for these species, it usually involves incorporating a lot of different objectives, not just related to the species, and a lot of different stakeholders and coordinating action across many jurisdictions, like across a whole species range. And that can be really challenging in and of itself. We also lastly have this high stakes problem where we know we have the potential for really bad irreversible outcomes. And a lot of times it's just hard to know where to start and how to make sure we're not doing harm to these species. That's the last thing we want to do. So what do we do when we face these challenges? We still want to do good for species. So the one approach that I'm going to talk about today is structured decision-making. And in short, if you haven't ever encountered this before, it's just a systematic approach to break down complex problems into a series of steps that we kind of navigate together with groups of people. And to me, this is really what structured decision-making looks like. This process is transparent, it's inclusive of perspectives, involves people throughout the process, and most importantly, it's pretty effective at solving some major conservation issues across a variety of contexts. And I'll just highlight, there was a recent case studies of structured decision-making book that provides a ton of different examples of how this can be used in different conservation contexts. So throughout the talk, you might see different tools that structured decision-making includes that can combat these challenges here. For example, when we're developing alternatives, a lot of times we use strategies or portfolios that are combinations of management actions. We also use models with the best available data and and expert judgment to evaluate and predict the consequences of different management options. Again, when we're evaluating consequences, a lot of times we can use scenarios that basically predict what's going to happen if we do those status quo management actions that we've always been doing versus maybe more strategic or different actions. And you'll see that today. Structured decision-making also makes explicit our objectives, and so we can better clarify those and evaluate the trade-offs that might be expected for one action over the other. And, all throughout the process, like I've said, this is inclusive of many different partners and perspectives. And I think that involvement really has so many benefits of giving people ownership of the problem and of the solution so that whatever recommendations come out of this process are likely to be implemented on the ground. And lastly, I think, the stakes are high and these structured decision-making applications do take time, but I think it's worth the investment in a lot of cases to really clearly think about the problem and come up with better solutions by going through a process like structured decision-making. And I guess one of the goals today is to basically convince you that it can be worth it sometimes. So let's dive into the case study here, focused on the gopher frog. So this is, if you've never heard of it, it's a southeastern species that inhabits isolated wetlands and also nearby uplands like longleaf pine savannas and related habitats. It is difficult to detect, very variable breeders, stochastic breeders, with very limited data in some parts of the species' life history. And it's also a species of concern. So there's a lot of management effort happening right now at the state level, and there's also a species status assessment forthcoming where it's going to be evaluated for ESA listing in a couple of years. So given that context, we entered into this problem with our stakeholders, and we defined the problem as wanting to identify optimal management strategies across these 183 potential gopher frog sites throughout the Southeast. And we wanted to optimize strategies to increase the distribution, number, and persistence of populations over the next 30 years. In other words, we wanted to know where and how to manage this species. So we sort of took this problem in like a two-tiered approach. And at the site level, our fundamental objectives, what we wanted to accomplish, are pretty simple. We wanted to increase the probability of a population persisting in the future. We also wanted to evaluate sort of across these conservation units. That's sort of where we're going to allocate management resources and where those best actions are going to be. So across conservation units, like this one here, we had 13 conservation units. We wanted to maximize redundancy, the number of persisting populations in the future. We also wanted to make sure that those persisting populations are spread out across these 13 conservation units. And we wanted to do all of this while minimizing cost. At the site level, what are we going to do to achieve those objectives? Well, working with our stakeholders, we realized that things are so different site to site. So we basically had them come up with a customized menu of management options for every site. And these options included a list of upland management, wetland management, and head starting, which was either not included or included in a strategy. And this has been starting to be used across most states in gopher frogs range and is a potential for establishing new populations. So we evaluated each of these strategies, these combination management actions, across every site and predicted population outcomes. Now at the unit-wide level, when we're trying to figure out best ways to allocate resources, we tested every combination of each strategy at every site. And those combinations we called portfolios. So one portfolio might be to do strategy 1 at Cedar Creek, strategy 3 at Conecuh, and so on. And so we evaluated what the outcomes of this portfolio are going to be versus the next combination of strategies, the next portfolio. We developed very extensive models to get in to estimating the consequences of these different actions. And we really used different data sets that we had at our disposal and I would say a healthy amount of expert opinion to fill in the gaps where we didn't have data informing the models. So at the site level, we started with predicting future habitat conditions based on upland management and current habitat conditions. Future habitat influenced future breeding frequency in these populations, and that really drove future population persistence. We developed ultimately a population viability analysis to estimate persistence under different management strategies that you saw on the last slide. And then we ramped that up to sort of a unit-wide level where we calculated the number of persisting populations expected given the management actions, as well as the cost of management. And these two objectives were weighted to basically identify sort of an overall value of how well each of those portfolios of actions performed. Now, just to give you a glimpse of some of the expert elicitation we did lean on our experts a lot to give us values of like expected effects of different management actions. So we would do things like give them a starting condition of a current habitat suitability at a site. Let's say it's 20%. And we said, what do you expect the future habitat suitability is going to be in 30 years given these different management actions? And so we were able to fit relationships between where your site is right now and where it's going to be in the future based on what management action was involved in that strategy. We did this for a lot of different management actions in our framework and combined it with the available data we had, like our estimates of current habitat suitability. For the unit-wide model, when we used optimization techniques that I can answer any questions about later on, but at the core of these optimization models, we were identifying how well each portfolio of actions performed based on its score of number of persisting populations and its cost score. That was sort of how we define success of a portfolio. Now the cost score, the main thing to take away is we just calculated the cost on a 0 to 1 scale. 0 meaning it was the most expensive action, 1 meaning it was the least expensive action, so higher numbers, better. And then on the number of persisting populations, we actually went back to our experts and we had them sort of rank how satisfied they would be with different numbers of persisting populations in the future. Because we sort of imagine there's a big difference in going from 0 to 1 population or 5 to 6 populations. So this sort of better captured their attitudes towards risk of different numbers of populations persisting in the future. So we converted this to an expected outcome of number of persisting populations that was between 0 and 1. Now we used 3 different scenarios where we played around with the weights we're going to give to cost versus population outcomes. And these 3 scenarios are as follows. First, we just tested the status quo scenario, and we said, what happens if we just continue baseline management in the future? And this functionally, that was our least expensive set of actions. So functionally, this is putting all the weight on cost and seeing what happens. We had a cost-effective scenario where we gave most of the weight to populations persisting, but we wanted to do that while minimizing cost as much as possible. And then we did a do-all-you-can scenario where we put all the weight on maximizing population outcomes regardless of cost and tested what combination of strategies are best under these different sort of weighting schemes or scenarios. So getting into the results of those extensive models that we made, first at the site level, we were able to use our models to estimate the future population persistence probability relative to cost of each of these management actions at each site. And I think what this does is gives us a good idea of what options sort of give us a good return on investment, like this one here, that our managers can use to make decisions on the ground. So in general, the more you spend, the more you get at a site, but there were some exceptions, like some alternatives were kind of what we call dominated, where the more you spend, you actually get a worse outcome than some of these other options. Pretty much always it was the case that if you wanted any decent persistence probability in the future, you needed to do things like burn the uplands frequently and a little bit of wetland management as well. So those gave us an idea of maybe best or optimal actions at the site level. But again, we wanted to know where to allocate resources across these sites. So I'm showing sort of visually mapped out what the model picked as optimal management actions across sites in Georgia under the cost-effective scenario and the do all we can scenario. And there's a lot of overlap. Most of these colors are exactly the same, except for these sort of 4 cases here, which I'll get into in a little bit. But in general, the model found that for cost-effective actions, there's sort of 3 types of things that were deemed optimal. One was keep managing our stronghold sites with high upland management and wetland management. Keep doing what you're doing and make sure those populations persist. These orange sites here, sorry, my mouse keeps disappearing, but these orange sites here are sites where the model said, you know what, just leave them alone. It's maybe not worth it. Put your resources elsewhere. And then finally, these blue sites are basically the priorities for head starting. So there were a couple sites in Georgia where the model said, these are the best places to put head starts out of all your options of head starting. And some of those include sites that are currently unoccupied. So functionally, this is like establishing new populations where they may have been historically, but they're not currently there. So a good mix of strategies here across our sites. And yeah, between cost-effective actions and do all we can effective actions, really all that changed is a lot of times some of these sites where they were sort of predicted to be not worth the effort. If we don't care about money, sometimes the model picked very intense, costly actions to implement at those sites. Like in this case, all these sites that originally it was optimal to do nothing at. And if we didn't care about money, now it's saying you should actually invest in head starting and doing extra habitat management there. So a lot to think about and a lot to give our stakeholders to really map out how they're going to allocate resources across the sites. And lastly, we ramped up our results at the statewide level and even range-wide level. And we looked at different outcomes and different costs for these 3 scenarios. So we had, for the status quo scenario, we predicted that on average, I should say, these dashed vertical lines here represent the current number of occupied gopher frog populations. And you can think of these as representing sort of like a mean and distribution of the outcomes predicted from models based on these 3 different scenarios: status quo, cost effective, and do all we can. So range wide, the status quo scenario predicted that even though right now we have 150 populations, in the future, we're only expecting on average about 51 populations persisting. If we do the cost-effective management actions, we're looking at 107 populations persisting. And if we do the do all we can management, that goes up slightly to 115. But I'll point out right here, moving from this number of populations to this number of populations costs $1 billion extra according to our model and our estimates. So you're getting about 8 extra populations on average, but it's costing you $1 billion more across the whole range for the next 30 years. So to me, this is sort of a good indication that these cost-effective options are really something to think about, and the model has honed in on ways to cut down on costs but achieve almost equivalent population outcomes, which is what we would have hoped for. But it's also sort of a good sobering warning that, you know, even under the do all we can scenarios, our models are still predicting a net loss of populations, which is something we need to think about very seriously. But, you know, going back to one of the challenges of the inertia problem and thinking about the business as usual approach and defaulting to that, one sort of explicitly looking at this status quo scenario versus some of these more strategic scenarios makes it clear that there could be a lot to gain by implementing management more strategically at different sites across the range. And of course, these sort of patterns aren't the same across every state, and some states have a good chance of maintaining or even increasing the number of populations they have under these under these cost-effective or do all we can management strategies that our models predicted to be optimal. So that's good news for some states, not so much Florida. but we're looking into what we might do to increase outcomes in Florida as well. And also just, I don't have a graph for it, but remember, we wanted to make sure that all of the conservation units were occupied with populations in 30 years in the future. And under the cost-effective management actions, that was likely to be the case, where 12 or 13 out of 13 conservation units were expected to be occupied. So these cost-effective actions are achieving a good balance between the number of populations persisting, cost, and then they're also achieving those representation goals that we had as well. So zooming out, what has this process accomplished for us? Well, I think we've sort of achieved good recommendations for conservation at scale for this species of the gopher frog. At the site level, we've given our managers something to think about in choosing good options with good return on investment that they could implement as funds become available at different sites. At the unit or statewide level, we've sort of honed in on clear recommendations of how to allocate resources across sites, which sites might be worth sort of abandoning or doing less gopher frog specific management, and which sites might be worth doing things like establishing new populations. And I can say that some of this is already happening, at least in Georgia, and as well as some of the other states. So that's very exciting. And then at the range-wide level, we saw that if we were to pursue implementing these cost-effective management actions across the whole range, it could achieve very good population outcomes and save a lot of money versus maybe stronger, more costly management that only might give us a little bit more bang for our buck. So going back to these challenges, again, I just wanted to highlight how this process has helped us and our stakeholders make explicit what those outcomes might be if we continue along the path we're going and just keep doing status quo management versus what we might gain by doing things a little more strategically and proactively. Now, the involvement throughout the process of people, I've been getting a lot of feedback recently of what people got out of it. And in general, our stakeholders have been really positive, and some of the best outcomes have been just coordinating and collaborating with each other and just getting in a room and talking about gopher frogs and getting that opportunity that they don't get a lot of time. So this, if nothing else, I've served a role of just bringing people together and letting them talk and learn from each other, which that's a good enough goal for me. And I hope people got a lot out of this process for that reason. And then again, I hope that, I've convinced you a little bit that investing the time, and this has taken some time. I think we started in earnest this process back in 2018 to frame out the problem and build these models and actually get some results in the hand of our stakeholders. But that investment, I hope, will be used to make on the ground decisions. And I have a sense from our stakeholders already that it's being used to go after funding in strategic ways, and actually they're already using it to basically reallocate where their efforts are going to be for this coming gopher frog season. So that's very exciting to see. So with that is all I have. I ended a little early, but that's a good deep dive into our approach for using structured decision making for the species. And there's obviously a lot of details we can talk about more, but I think I'll just stop there and open it up for questions and say thank you all again for coming this morning.
Thanks, Brian. That was a great presentation and some really cool images too. What's cuter than that little frog there in the corner?
Yes,
so anyway, yeah. So
that's not my picture. I think Kevin Inge took that one. I'll give him credit for it.
I think I found some of his as well.
Mm-hmm.
Anyway, no, that was really great, and thanks for allowing lots of time for questions. So, so I would say that we have 60 people online, but if you would like to raise your hand, we can maybe do this in orderly fashion. And Ashlyn showed the the bottom banner of your of the Zoom interface. In that reactions bar, you actually can raise your hand. If you click on that, you actually have a raise hand function in that if you wish. And I can allow you to unmute yourself, or you can throw a question into the chat. box, whichever you prefer. So, Jean, you want to go ahead and ask your question?
Yes, thank you. Thank you so much, Brian. It was interesting. I really like the range-wide approach and showing that example. My question is, I guess, in two parts. So one, in terms of how you engage the experts as it relates to climate futures. And so the threat says they relate to, changing climate or droughts and things like that. So, so I'm assuming that was put into your expert elicitation in that process. And then the other thing was the issue of the modeling itself. And so I see the cost effectiveness, but I'm wondering if there's something in there that you can look at in terms of discounting into the future. So whether that's disease or land use changes, et cetera. So is there a process identified to reevaluate the portfolios based on emerging anthropogenic or climate-related stressors into the future?
Yeah, those are both really good questions. I'll say first, we didn't explicitly look at discounting. We definitely didn't include that, but we certainly could, because our models, predict in the future, and we could easily, incorporate that. Our time frame was 30 years, so that wasn't an issue that our stakeholders raised. They seemed to be comfortable with sort of just making a plan to enact for 30 years and then judging the value of those outcomes as not depreciating over time. But yeah, certainly something that we could put in the future. Also, with the expert elicitation of, I guess I want to speak to that in two ways. One, climate change, again, 30 years, I think drought and the frequency and intensity of storms is going to hugely impact the species. I don't think we implicitly asked our expert to say, what is the impact of that part of the system on the species? However, it was definitely in the back of their mind when they filled out some of those expert exercises that we gave them. So we would ask them, if you do head starting, what's the chance of persistence 30 years in the future? And no one ever said it was 100%. They were always thinking about those stochastic environmental elements. And I think for the species, it definitely was related to drought conditions and things like that. So yeah, we didn't explicitly tease out the impacts of climate change, but I imagine it was in our experts' thinking and how they interpreted the risk of some of these actions in the future, and nothing ever being certain. So it was accounted for implicitly in that way. And the last thing I'll say about that is, with these population viability models, actually, I might just scroll back to show you a little clearer what I'm thinking. We have plans to investigate that in a little bit more detail. So seasonal precipitation was one of the factors in our breeding frequency model. So we used sort of the last 10 years of seasonal precipitation and the last 10 years of breeding data. And that was a huge, that was a major influencer on this outcome. So what we have planned actually is to simulate different drought intensities and frequencies and actually run this population viability analysis for the gopher frog that simulates what are the likely outcomes going to be under those different sort of drought scenarios. So that's something we're currently doing. We've started to do it a little bit, and plan in the very near future to examine the influence of that a little more explicitly. But I know that getting actual predictions that are downscaled and reliable for some of those climate change variables are going to be difficult. I don't know the status of them right now, but we could fit those models to predicted data for the future of drought frequency and stuff. I know some of those data sets are out there. I haven't looked into them yet, but if you are more of an expert on those and want to send me some good data sets to use, we are definitely interested in incorporating them into some follow-up work.
Thank you.
Yeah, thanks for that good question and response. So this is maybe related, and I don't know, Brian, if you can see the chat window, but I think, this question about your habitat suitability models, that projected future suitability under climate change, I think you alluded to that was not the case. Is that right?
That's correct. These habitat suitability models are current suitability, and then future was done with expert input only. So again, they were thinking about all sorts of areas of uncertainty, including climate change, when they fit these type of estimates to what the future habitat and population outcomes are going to be under starting conditions and different management. And I'm not showing the error bars here, but you can imagine there's a lot of uncertainty around these estimates that we did include in the analysis.
Great, thanks. I don't know if you want to address the follow-up. We can read it out. Did you do a sensitivity analysis, wondering which parameters had the biggest effect on your predicted outcomes and which you wished were more certain? Yeah, we did. Good question. So I think I glossed over it, but I included it here in the results that at the site level, in that persistence model, the population persistence was very sensitive to starting abundance, like basically starting conditions were the main drivers of it. Starting abundance had a big influence. Breeding frequency had probably the biggest influence. Fortunately, we had at least some data to estimate current breeding frequency for a lot of these populations. Those were probably the two main ones. And just going back to like how little we know about the species, abundance of a lot of these populations is very hard to detect because they're such sort of explosive and variable breeders that it's really difficult. So we were relying on expert opinion for the starting abundances, and that did influence what the likely persistence probabilities are going to be. Those are the main things. I feel like I had another. Oh, and we also tested sensitivity to these weights. So we did run another scenario where we had 50% of the weight on population outcomes and 50% on cost. And really it was so similar to this scenario that we just went with this one. Sort of the model picked basically very similar optimal actions for most sites. So we did test the sensitivity to that weight choice as well. Yeah, it looks good. You can see the one from Brian. Yes. Yeah, any patterns that emerged, characteristics of site that were recommended not to receive any effort. Yeah, thanks for the question, Brian. Definitely. It was usually the case where you can see a lot of these orange sites are hatched, meaning they're currently unoccupied. And a lot of these, at least these three, are on private lands. So I didn't go into it, but we ran a scenario where to work on private lands would require you acquire the land. We also ran a scenario where to work on private lands, you can imagine working with the landowner, gaining access to the land, but not having to outright acquire it. And when you had to acquire land, a lot of the private sites, it was basically not worth the acquisition cost to then do further management there. That changed sometimes when we sort of adjusted it to say, well, what if you could work on that land without having to acquire it? Sometimes those sites switch to maybe doing more habitat management, but a lot of times they did stay sort of in a do nothing approach, often because a lot of those are currently unoccupied, and there's just a steep sort of hill you have to climb to establish populations there. But yeah, definitely private lands, maybe with lower habitat suitability to start, were the ones that the model tended to favor as, just leave them alone and focus your efforts on more on the stronghold sites or the sites that are really, really valuable for potential head starting. That's interesting. Can I ask sort of a related question? Yeah, sure. So were there other potential stakeholders, other landowners, NGOs that you feel like could have been involved in this, or did you pretty much hit the distribution that you wanted with the lands that you were
Yeah,
working.
there are definitely other stakeholders I wish we could involve. The challenge is in these structured decision-making workshops, they can easily become too big where you can't really have good discussions, but you want to include everyone. So we kind of focused on federal and state agencies because they managed the majority of lands, but obviously they don't manage all of this. So I think two groups that come to mind are maybe through the Longleaf Alliance or some of the Longleaf landowner associations, we maybe could have connected with them, and perhaps they would have represented multiple landowners across the sites we were interested in. We also, I think, could have done a better job sort of involving the on-the-ground fire managers. We relied on our state biologists to provide us with a lot of the constraints and estimates for what's possible in terms of fire management and what we have to think about for this planning process. But I think getting fire managers into the room, because fire was such an element, such an important element to most of these optimal strategies, that could have been better and perhaps would have highlighted some different options or different constraints that we could have thought about. Right now, just on the back end of giving these results to our state biologists, they're going to take them and sort of coordinate with the fire managers to see if, what the likelihood of some of these actions being implemented is. But that's something that's going to have to be done on their end instead of incorporating those voices in early in the process. So that's something that we probably could have paid more attention to at the beginning.
Yeah, right, thanks.
Sure.
Yeah, so it looks like, Jean has another question about opportunities to show the benefits to other non-target species and integrating that into cost benefit calculation.
Sure. Yeah, it's a good question. At the original SDM workshop, that was one of our other objectives that we talked about. We figured for the point of this process, we were going to focus on gopher frogs, but obviously most of these actions, except for head starting, will benefit other at-risk or species of concern. So burning uplands, doing good wetland management, there's a lot of priority amphibian species that use those wetlands besides gopher frogs. So we sort of settled on, if we can achieve, if we're identifying good management for gopher frogs, it's going to benefit other species. So yeah, head starting was kind of the only thing that directly affected gopher frogs and not other species. But we made that judgment call of leaving that objective off the table for now and assuming that, if we're meeting these objectives, at least in part, we're meeting other objectives for other at-risk species.
Yeah, great.
Yeah.
And I guess another by Jennifer, how variable was the status quo across these states?
Yeah, that's I didn't go into that too much. It's very site to site. In general, so let's see, let me get back to, these are all great questions. I love it. If we go back to this table, I would say most sites, the status quo, like what they're doing right now on that site, fell into strategy number 1 or number 2, maybe number 3. So we're talking, especially on private lands and stuff like that, we're talking maybe limited burning, which for us is every 5 or more years. High burning was sort of the frequency that we think is needed to maintain good longleaf habitat and gopher frog habitat. That's every 3 years or less. So yeah, most of the status quo actions across sites were in those first two, are represented by those first 2 management actions. Every once in a while, status quo would be doing a little bit of wetland burning as well.
Yeah, and I guess interesting question by Brad there about whether you encountered resistance by federal management agencies, or did you have to convince them to care?
Yeah, I have been getting feedback this past week, sort of asking that question of like, what were the benefits from their perspective, and what could we change in the future? And most of the, I think they all they all care about the species. They were all pretty amenable to being involved in this, whether passively or actively amenable, sort of varied partner to partner. But I think for them, the biggest constraint is just time and money. And some of them aren't really like, I don't know, like this is sort of an extracurricular thing that they're not even being compensated for. And it takes a lot of time and involvement. And they gave so much to this process, all that expert input, a ton of meetings and stuff. And, you know, we tried to do what we can and make it as efficient as possible. But this was a big ordeal to come up with a range-wide management plan. So yeah, we were constantly sort of having to make things as efficient as possible, but also at every step of the way, they had these good ideas about things to adjust in the model. And we're like, well, we can do that, but it's going to take a little more time. And then we would, you know, go through the cycle again and improve our process. So there was definitely some trade-offs in terms of the quality of the product we're making and the amount of time it takes everyone to be involved in it. I think, I mean, there's a lot that we could talk about with this question, and a lot that I don't necessarily know. Like, we don't know how these results are going to be used. We have some indication that certain partners are very excited about them and already using them to go after funding and implement different management on the ground. And others might, you know, sort of keep these in their back pocket and continue doing good things for the species, but maybe not take as much of it, you know, not take them to heart as much as other partners. So I think time will tell how useful these are across the whole range of the gopher frog, but they definitely are already being used by some partners, and that's the best outcome for me. Beyond that, like I said, we had a great group of stakeholders who really liked working together, and you could tell that during these meetings there was so much sharing of knowledge and learning across the range of the species to be like, oh, that's a problem you guys have here. Okay, this is how we deal with it, but you're dealing with it in a different way. I wonder, you know, like, let's compare notes and see, you know, who's doing it better, learn from each other. So there was a ton of that. And I know that every stakeholder who I asked mentioned that as one of the benefits of this process. So they got something out of it, even if it was just good discussions and learning about the species.
Yeah, great, thanks. So I guess to that question, or to that I would add a question. So maybe it's twofold. One is, you believe this process is one that can be replicated for other species in other areas.
Yeah.
And B, how would you suggest someone allocate the time and the resources to do that if they were interested in taking that on?
Yeah, that second part of the question is really, really difficult. I would say this definitely can be replicated, and it has been replicated for a lot of species, including herp species in the Southeast. And the reason I kind of smiled when you asked that, Carrie, is because I'm doing a joint presentation on the same topic for Sea Park in a week, I think. And I'm doing it with Katie O'Donnell and Connor McGowan, who are other SDM practitioners in the Southeast. And they're going to talk about 3 other case studies where they used SDM for flatwood salamanders, indigo snakes, and the red hill salamander in Alabama. So it's being practiced a lot and applied more and more frequently as the years go on to combat a whole bunch of conservation issues, specifically for herps in the Southeast. So the funding issue, it's really difficult. I don't know exactly what institutionally needs to change. I think that the Fish and Wildlife Service, I'll give them credit, they funded my research to lead this. And that was, you know, sort of thinking proactively of, they have a lot of species that are up for listing soon, and doing things like this and coming up with more proactive conservation plans and also analyses that predict what's going to happen to the species in the future. I expect most of this research is going to be used in their species status assessment. So it benefits, you know, some of their needs. And then, you know, they're putting at least some money in for workshops and things like that. So maybe more of that to start. And then at the state level, I know their budgets are a lot more limited, but somehow giving these state biologists credit for participating in these things should happen, I think. And I don't know what that looks like, because I'm not sort of involved in that system, but that would be a great outcome in the near future. Hopefully, after we see more evidence that the process is worth it, which is the challenge.
Yeah, because it's a lengthy process, as you mentioned. Yeah, and I will put in a plug too that, especially by having, Mitch Eaton on our staff, we are trying to train the next generation of, professionals in some of these SDM strategies and hopefully building the capabilities of folks who could take this on in a way.
And I'll just say it doesn't have to be, nothing about SDM has to be lengthy. There's a version of it called rapid prototyping where you sort of go through that wheel as fast as possible. And even that can have some real benefits of thinking more clearly about objectives and thinking about the big trade-offs. And sometimes just reasonable management actions or decisions will emerge from a pretty quick version of the process. I think I tend to complicate things and build these crazy models and stuff. And so we dove deeper and did a longer, more detailed process in this particular case. But yeah, SDM isn't inherently lengthy. It just takes some very strategic thinking. But you can invest a lot less time to start an SDM application and still see some benefits from it.
Mm-hmm. Yeah. Very good. Okay, so it looks like Lars has put a question in the box too. Thinking again of the sensitivity analysis, what about sensitivities to model parameters, uncertainties of the different outcomes among the scenarios, cost efficiency versus going for broke? The differences among scenario outcomes pretty robust to various model uncertainties.
Yeah, I mentioned this a little bit ago. I don't know if you were kicked off or something, but we tested all sorts of sensitivities in the model, including starting conditions and how that influenced persistence probability. And then with the scenarios, we did evaluate another scenario where we sort of had 50-50 weight on these two objectives. And it really, basically the model was pretty insensitive to specific choice of weight. As long as you gave some weight to populations and some weight to cost, most of the optimal management strategies were the same for sites. I forget the percentage. I have that somewhere, but we did look at the sensitivity to that. And again, between the go for broke, do all we can scenario and cost effective, a lot of actions were the same across those. And often what changed is doing things like really going for it at some private lands where it's like, it doesn't matter, even if we have to acquire it, we're putting as many gopher frogs on the landscape as we have the capacity to. That's usually what changed under the do all we can scenario. Yeah, but again, a lot of these sites had the same best management action when we looked at the cost-effective scenario and the do all we can scenario.
Yeah, great. Yeah, thanks, Brian, for fielding all these questions. This is a great discussion. So
yeah, I love it.
Yeah. So are there any other questions from anyone else on the line here? Feel free to raise your hand, or we did want to allow a couple of minutes to sort of wrap up and let Ashlyn show us what we have in store for our next seminar as well. But I think we have time for another if there's anything outstanding. Right. Well, thanks again for all those questions and answers. So Ashlyn, you want to show us our last slide then? I'll let you take it from here.
Yeah, thanks everyone. Those were really great questions, and definitely email me if you have any follow-up, but I really enjoyed it.
Yeah, great.
Yeah, thanks for that presentation, Brian, and to everyone who posed a question. That was a really interesting discussion. Just want to wrap up the presentation today quickly by letting you all know about the next presentation in our Spring Science Seminar Series, which will be held on March 16th at 11 a.m. Eastern Time. That presentation will be given by SE CASC research ecologist Adam Turando on the topic of using information from global climate models to inform policymaking and natural resource decision-making. That should be a pretty interesting discussion, and we hope that you'll register and plan to join us for that presentation. Just a quick note, just want to let everyone know that by registering for today's webinar, you'll also be subscribed to our monthly newsletter list, where you'll be able to learn about some of these upcoming seminars, as well as some other events. So of course, you're welcome to unsubscribe yourself at any time. But yeah, thanks everyone for joining us today. And thanks again, Brian, for that wonderful presentation. I hope everyone has a great rest of your day, and please continue to stay safe.
Thanks again.